All right, so let's talk about distributed operating systems. Um, so this is where we take the concept of an operating system that we've talked about, and we take the concept of cloud computing that we talked about, and we marry the two of them together into a single solution that we're going to call a distributed operating system. So the idea is, and this is actually, it's almost like we historically did something like this, then went away from this, then came back to this. So let's say 20 years ago, 25 years ago, there was something called dummy terminals. And you maybe even messed with this in Locklear's 150 class. If he took you into this room over here, he has a wall of stupid computers that they're all hooked to a single box. Well, they're called dummy terminals. So the idea is, think about in this room, we have all these monitors and towers. Well, let's just say we had one tower in this room, one computer in this room. And all of these monitors, keyboards, and mice were all somehow hooked into that one computer. And they were getting, so all your computational power was coming from that one box, and you were sharing it across all those machines. And the operating system that box was projecting allowed multiple machines to log in at once. So historically, that would have looked something like our terminal screen here. So I would have logged in, so there probably wouldn't have been a mouse, but I would have logged in, I would have seen something like this, and I would have had a keyboard, and that would be my screen. It was just this text-based thing. And there was actually a computer over in the corner of the room or something like that that was actually driving this. Okay, so this would have been kind of our early local area network type solutions where you had one gigantic computer and a whole bunch of terminals for accessing that computer on a local area network. All right, well now we can accomplish a similar thing by telnetting into another machine somewhere, but that's not our modern view of what using a computer is, right? I mean, historically, this was a computer. I would come in here and I would edit a file. I would be editing this. This is how I would write my papers. So that's not what we think about when we think about computing anymore. We think about this type of thing. Graphic user interface and folders and a bunch of applications you can launch by just clicking on them, that kind of stuff. So that's kind of what we view as being our computing today. So as our operating systems got more and more complex, because we had to go from that text-based interface to our modern-day graphic user interface, this idea of using dummy terminals went to the wayside. The bandwidth wasn't there any longer. So think about early local area network type technologies. I mean, the best they can do is send text. Once upon a time, if you were going to print a big document, just sending that document to the printer over a local cable was super slow. It might take 5 minutes to send a document to the printer. Forget about the next 45 minutes it would take to print if it was, a 50 or 60 page document. So we've come a long way. So our expectations of our operating systems today are completely different than they were back then. So having said that, what we want is we want to have a dummy terminal type of situation. Maybe in the short run, in a classroom like this, we would have, how many we have? 1, 2, 3, 4, 10? 10 machines or 10 workstations, each connected to a single central computer. So maybe that's what we'd like to accomplish. But each of these machines is running Windows, would be the idea for our local example. So I would sit down at this machine and I'd be running Windows, interacting with it just like it was a local Windows install. I could connect into it and I could install applications here, and that would be my machine, so to speak. Somebody else, a couple of machines down, could install their own applications there, and it would be their machine. Yet all the horsepower was happening in the big computer in the corner, something like that. All right, so you're on one dummy terminal, but you're using a modern operating system, and one centralized computer is giving you all the horsepower. What's the advantage of something like that? So that we need to almost roll ourselves back 10 years. Because now we already have seen that going to a computer lab is an inconvenience. We view it as that, right? You'd rather just work on your own machine if you can. True statement? Okay. So, let's go back to when going to the computer lab was considered the cool thing to do, or the right thing to do. All right? So, what's good from an IT perspective, maybe, about having 10 machines all being controlled by one piece of hardware? Potentially cheaper.
It's all in one spot.
Yeah. All in one spot, so you're fixing something only in one place, one point of failure, which actually maybe is a bad thing. In a situation like we have in here right now with 10 machines, if this first machine goes down, that doesn't mean the other 9 are affected. But having that centralized thing could be a problem. Because then nobody can use the operating system. Okay, what else is good about it? Seems like right now we have a mixed bag of good and bad. Does it make each individual workstation install a lighter weight, simpler install? Basically, what do? You plop down a monitor, a keyboard, and mouse, and plug it in the network. So you have a single power plug and a Ethernet cord, and you have a computer. That's it. So that seems to be advantageous, right? Same thing. What about heat? Heat and cooling. So if you have all these machines in a single lab, and you have the big computer off to the side in a smaller room, you can cool that one room where the giant computer is, and not have to spend as much energy cooling the bigger lab, because the machines aren't going to be giving off as much heat. Does that make sense? So another advantage. Okay, what's the disadvantage?
You have to travel to the place.
Oh, okay. You got to go to the lab, but we're still stuck 10 years ago. We're going to the lab was a common thing. Well, was it? So we have 10 machines now. Don't you think we're probably going to expand to 20 machines before long? Just add more machines. In a situation like this, if we want to add another machine, what do? Call up Dell, order another machine. Machine arrives, and now we have another machine. No harm, no foul. Right? We install the new OS, blah, blah, blah. Okay. For the cost of one additional machine. And it doesn't hurt the performance of the other machines. But in the big scheme here, with our example of the dummy terminal version of this, when we add an 11th machine, now 11 machines are sharing the horsepower of that one computer, rather than 10 machines sharing the horsepower of that one computer. So adding one more machine, on paper at least, degraded the performance of all the machines. Seems to be maybe not what we want. Okay. So do you think that we're going to move back to this dummy terminal type thing? It seems to be inflexible, doesn't it? You pretty much need to know how many computers you're going to have right off the bat, and how much horsepower that one machine needs to have to power them. The second you start adding more machines to that, you're playing with fire in terms of when you degrade the experience for everybody else. What's the fix for that? We're adding a computer where we can take advantage of the benefits of cloud stuff, that is, stuff stored elsewhere. Yet adding a computer gives us the, does not degrade horsepower, does not degrade our performance. What percentage of the time does a computer sit idle? A normal modern day computer? a high percentage of the time, right? 98, 99% of the time, the processor's not doing anything. We've previously discussed about some of these tools like SETI Online or SETI at Home and distributed.net, things that take advantage of your idle CPU cycles, right? Programs that run on your computer. What if instead of this dummy terminal concept, what if we had 10,000 computers, full-fledged normal computers, okay? And these computers were all networked in some way. How hard would it be to network those 10,000 computers?
However long it takes to network 1 times 1,000.
Well, out of that 10,000, how many of them you think are on the internet? Probably almost all of them. They're already networked. We have access to them, right? The only thing blocking us is firewalls and things like that. And you can open those real quick. That's why LogMeIn works. How many of you have ever tried to remote back into your computer directly, try to run a web server or something like that on your computer and couldn't reach it because your cable modem provider, DSL, was blocking the internal connection. Yet you install LogMeIn on your machine at home and it works. Why? Do they implement their software more better than the web browser, the web server that you tried to put on there?
Maybe LogMeIn is listed as one of the exceptions on your firewall for your provider.
Wouldn't be. That wouldn't be the case. To draw some pictures for Dane. Here's Time Warner Cable.
Horrible.
Cable modem provider. And here's our Apache web server that we're going to install on our computer. And that's our PC. Now we have another PC somewhere who's trying to access this web server. So maybe this PC has that IP address. All right, so Apache is actually running, is a piece of software running on that PC on port 80, web server port. All right, so now this computer, oh, that's not what I wanted. Didn't I have don't I have a drawing one? Aha! So this PC is going to try to access this PC specifically on port 80. So it's going to open up a connection, HTTP, 143.43.243.11, port 80. And that's going to send them into, it's going to ultimately take them through this firewall set up by Time Warner Cable, possibly down to, and try to get to your PC, and your PC is going to block it. Now, one possibility is Time Warner Cable actually has the IP address of 143.43.243.11, and your PC actually has an internal address, 192.168.1.231, something like that. Okay, this is called a non-routable IP address. It's only a unique address amongst Time Warner Cable's network. All right, so now this person's trying to reach 143.43.243.11, and that's actually taking them to Time Warner's thing. Because if they try to reach 192.168.1.231, there's probably a million of those addresses that are unique. in the world, because each one's living inside of a smaller network. So this is one way they might block the firewall, by giving you a fake internal address. How many of you have looked at your IP address in your machine in your at your house? How many of you have an address that either looks like this or 10.0. something, a 10 dot number? Either of those two, they're non-routable IP addresses, but they're this guy. So your machine is actually not directly connectable. It's not unique in the world. So that phone number doesn't get them to your machine. Other people, they might get a real IP address, 143.43.243.11, and maybe Time Warner Cable has whatever their address is. It doesn't matter. But ultimately, in order to get to your machine, somebody's going to have to hit the edge router at Time Warner Cable, and they're going to block it. They're going to block any incoming connections to your machine. That's firewall. Keep stuff from getting in. So, at the end of the day, your Apache server does not work. Your web server you're trying to run on your machine, you can hit it locally. If you're sitting behind your firewall, if you're locally on your machine, you have Apache up, you go to your web browser, you type in 143.43.243.11, it'll go to that page because you don't have to leave your network and come back in. You're doing everything locally on your machine. Does that make sense? Yet, in this exact same model, log me in, and a host of other applications work just fine. No problem. This person tries to connect to log me in at this address, and they're remote controlling the computer. No harm, no foul. Why? What's the difference between log me in and Apache? How many of you have ever installed a web server on a computer? Let's see, what would be another equivalent? Well, Apache, this piece of software, only exists on your computer and sits there and listens on port 80 for somebody to connect to your computer. Log me in has a cloud, a website, if you will. And what happens? When you connect from your log me in client, so you'd have the log me in client on this PC, which is probably going through the web server or website. You connect from the log me in client to the log me in cloud. The log me in server that's running on your PC at home constantly opens up a connection to the cloud and leaves the door open. Okay? So this server, the guy is listening at your home computer. It opens up a connection heading outwards. Firewalls don't block that. They block things from getting in, not from blocking things from going out. So the log me in server, the piece of software running on your computer, opens a connection to the cloud and keeps it open. Then when you connect in from your external PC, you connect to the log me in cloud, and what ends up happening is it bridges that connection. So this door was already open. So now it just connects these two ends together, and now you can communicate between these two. Does that make sense? So that's how log me in and other applications work, and that's why running something like Apache would not work. You would have to create a local piece of software maybe you call this the Apache hack. You could write it in Java or something like that. What does the Apache hack do? It's going to connect to the Apache hack cloud, And then when this PC tried to reach your Apache server, they would actually go to the Apache hacked cloud and maybe put in a unique identifier of what your server is. And that could then serve the information because this software would maintain an open connection here. In essence, opening the door. That kind of makes sense? So punchline here is that there's nothing that keeps us from having something that's running on our local machine that's constantly, when we see it with Dropbox. Dropbox, it doesn't even matter what network we're on, does it? As long as we're on the internet somehow. It doesn't care about your IP address because it's the local application that is talking to the cloud to keep it in sync, not the cloud that's talking to the local application. Cloud doesn't, I'll call you, you don't call me, type thing. All right, so this model currently exists. So what would keep us from having a distributed OS cloud we'll just do a simple example with 3 computers. Well, awesome. Sometimes I even surprise myself with that kind of crap. So all of these PCs are running the distributed OS server. Actually, we could think of it as the client. It doesn't really matter in this case. In fact, we'll call it the client. No, actually, I know that might seem stupid, but this is actually more accurate. Okay, so each of these PCs is running the distributed operating system client/server application, just like you downloaded LogMeIn and installed it on your machine. Okay, then up in the cloud somewhere, we have our actual distributed operating system cloud piece. Okay, whatever that ultimately means. Now, every single one of these PCs, when they get turned on, they're on the internet, right? They're going to open up a connection to the cloud. Now, the cloud has its own CPUs/storage. So it has its own computing horsepower as well. Okay? So it can do its own computational stuff. It can even do some computational stuff from these machines. But, like we said, each of these computers sits idle 98% of the time, or a very high percentage of the time. So let's say this computer right here is doing some computationally expensive stuff. Stuff that would take a long time to do locally. Yet these 2 computers are doing nothing right now. Wouldn't it be beneficial for us to have these 2 computers help us do the computationally difficult work on this guy? Absolutely. Now multiply that problem by 1 billion computers around the world. So now you have 1 billion computers, 98% of which are sitting idle 100% of the time. I just flip the statistics upside down. Still works. right? So we're saying 98% of those machines are doing nothing at any point in time. So we can utilize them. So in that particular case, a distributed operating system actually sounds like a good idea, doesn't it? We have all this horsepower around the entire world that we could be utilizing to help us solve problems, including probably this supercomputer up here in the cloud that's all helping us solve problems. What did you say?
It said aliens.
Aliens, that's right. That's what I was thinking. So, that's the problem we're solving. What's good about this?
If you're not using your computer, I don't know, your computer's sitting free and just idle, you're not doing anything. Why not use it for a purpose?
Okay, so if we take all the world's computers that are connected to the internet, just as an example, let's just call that 1 billion computers. Fair enough? So we're going to take 1 billion computers. Would you say that, at least loosely speaking, 1 billion computers gives us unlimited processing power and unlimited storage? By today's standards, we have infinite processing power and infinite storage. Now, could we do a lot with infinite processing power and infinite storage? I mean, consider Skippy's got this crappy laptop sitting there. Isn't yours crappy too?
Yeah, both of them. But this one's broke at the current moment. So
I see. So in any case, what if that machine wasn't as antiquated as you think it is? What if its computational capacity was not limited by what's actually inside of that computer? So how many of you have a really, really, really good gaming machine at home? Pretty decent? Pretty decent? Okay. How many of you have a crappy machine at home?
This thing.
Okay. Now, what kind of network speed card do you have in this guy? How old is this guy?
4 years.
Okay, it's 4 years, so does it have an Ethernet port in it?
I think so.
Okay, I'm guessing if it's only 4 years, it's probably a gigabit Ethernet port. And it probably supports 802.11n, correct?
Yeah.
Okay, we don't even need to worry about that so much. Your gaming rig at home, Ethernet port in the back of it?
Yep, that's what I use.
Okay, also gigabit. Network speed, the network capability of this laptop and your machine at home are identical. Just as much information can move in and out of those computers over that Ethernet port, even though this machine is a fraction of the power of the machine at home. Now, what if the horsepower that your computers could utilize was mostly done through that Ethernet port and not done locally? That seems like it would be a good thing, right? If I could somehow share in the rest of the world's computational power. This is how cable modem service actually works. Cable modem service is a shared bandwidth type of service. That is, if you have, Time Warner is going to deliver X amount of bandwidth to a neighborhood or to what they call them cells. And then if everybody in your neighborhood is online all at the same time, downloading something, let's say just some big file, so they're literally trying to maximize their internet connection, everybody won't get as much speed as they usually do. So one of the reasons that if you have a 50 megabit per second internet connection at home, one of the reasons that you can actually get 50 megabits per second is because enough other people on your current cell aren't using up the bandwidth. The bandwidth to that cell is more than 50 megabit per second, but it might not be more than 1,000 megabit per second. It might not even be 500 megabit per second. So that means if 10 people are trying to max their connection, or if 11 people are maxing your connection, you're being constrained.
Yeah. That's technically why your computer is set default to upgrade itself at night, because less people will be on the service packs. Because they're usually big files, aren't they?
Well, yeah, but that's not why your computer does that. Your computer's set to do it in the middle of the night so that it's not using processing power locally while during the waking hours when you're probably using your computer. You might be playing a video game or working on a paper or something like that. You don't need your computer busy doing other crap, taking away from, you want your computer doing that when it's during its 98% of the time that's idle,
Okay.
not by the time that you're sitting there actually using it. So it has much, much, much more to do with that than it does with caring about bandwidth.
Okay.
Well, so in any case, this model seems to be a good thing. We get computational horsepower that the whole world is sharing with everybody else. What's wrong with this model? Why might this be a bad idea?
For security.
Okay, possibly security. The second we're giving people access, if you could somehow hack this guy, now you have access to every person's machine in the world, by our example here, assuming they're all connected in this one place. Okay, so possibly a security issue. Now, having said that, though, doesn't this problem already exist from a security perspective? If somebody hacked Google, wouldn't they have access to a lot of people's machines? And so we're going to say security problems exist anyways. With this, we at least know that we only need to make this guy Fort Knox. So we can put all sorts of security protocols. Like, do you think hacking Google is probably difficult? It probably would not be your number one target because it would be equivalent to breaking into Fort Knox as opposed to something else that might be equivalent to breaking into a corner store that has its door unlocked. It's a trade-off. Now, the value of the information and the value of the access you'd have at Google is far greater, but there's a fighting chance you might get it over here. There's a slim to no chance you're going to get it at Google. So we could probably lock down one facility or a handful of facilities rather than locking down 1 billion computers. So security is certainly going to be a concern and something that has to be addressed, but I think it's a problem that we could solve. What else is wrong with this? How many of you would be willing to share your idle CPU time with other people? Give me a reason why you might not be willing to share it.
If you're famous and you don't want people getting into your files.
No, they're not accessing your files. They're just accessing your CPU, CPU and RAM when you're not using it.
It's all a conspiracy.
Is it?
Destroy my computer.
All hardware has its life cycle, and you don't want it to burn out any faster than it potentially would.
Okay.
So if you're overclocked, if you're using it all the time.
One possible thing is that it will reduce the lifespan of your hardware because other people are using it more. They're using it more than it would have been used otherwise.
It gets hot very fast.
How many? Let's switch up the. Let's assume they would never get in a car accident. How many of you would let anybody come and borrow your car whenever you weren't using it? Bring it back, leave it there, and it was always going to be there exactly when you needed it. So you would never be inconvenienced that you need your car and it's not there.
And I'm not worried about them
What about
breaking
the
it.
gas?
Oh, what about the gas?
Well, see, now if I get to drive their car anytime, they're not using it, then it might be okay.
Interesting counterpoint. So first thing is you're saying, okay, well, what about the gas? They're not refilling the gas. They're using your gas. So you only come out ahead if you use their car at least as much as you use your car, or you use as much gas of their car as that type of thing, right? Then it's a break-even point. How often if we translate that across 1 billion computers, do you think it's going to be break even? There'll be a percentage, right? But more times than not, you're going to have a lot of machines that are sitting there idle, lightly used machines. And then you're going to have a lot of machines that are being used heavily, taking advantage of all the other people's machines, right? The gas equivalent is electricity. So just because grandma's hardly ever on her computer doesn't mean she wants to pay more in electricity because you have her CPU pinned out all the time. Does that make sense? So how might you solve this problem? So I'll start this off by saying distributed operating systems have been a pipe dream for a relatively long time. And they're probably more accessible now than they've ever been in terms of actually being able to do it. But there's all sorts of problems, and we're just starting to hit the tip of the iceberg of some of these problems right now. How would you solve even that one problem? It's not so much out of human greed as it is just practical. You don't want the computer that you paid for to break sooner than it would have otherwise. I mean, maybe you got the budget pleaser computer because you knew you were going to be a light user. You didn't need the industrial strength enterprise hard drives. You didn't need the extra, protection care on it, and to fix bad hardware, things like that. You didn't need all that stuff because you're going to be using it to check your email once or twice a week. Using that as an example. Maybe you also got a laptop so you can keep your lid shut so you're not using electricity. Well, now, for the greater good, you have to leave your machine on all the time so other people can share it. Well, you don't have to, but assuming you're going to participate in this global operating system, which you probably wouldn't get 100% participation in, but there would be a group of people that would participate, probably a large group. What would it take to convince you to do it? So assuming you're going to have a computer, you're going to leave on all the time, you're going to participate in this global thing because it does benefit you sometimes. And, we're just assuming we can pull it off. We're going to talk about operating system type problems, once we get past the human aspect of this. So assuming you can pull this off, what is it going to take to convince you? We can simplify it down to as long as it won't cost you more money in the long run, right? Wouldn't you agree that generally speaking, that's that will be most human beings' approach to it? As long as I will end up in the long run spending no more money than I would have otherwise. That is the hardware, maybe I'm supplemented in some ways for the hardware that's being used. Maybe it's a credit type thing, where when you use somebody else's hardware, you're spending credits. When somebody else is using yours, you're gaining credits, and maybe it's kind of a balancing act type thing, where in the end, the idea is it's a wash in terms of what you would have spent on your hardware and stuff anyways. That seems like it's possible. It kind of goes along the lines of Dane's, as long as I can borrow their car, and their car is more better than my car, and they get worse gas mileage, and I drive it a lot more, so I can screw them over. Rather than using my all of a sudden Dane just abandons his car altogether. I'm just using other people's cars. Eventually my car runs out of gas, they'll stop using it. If they want to use it, they'll fill it back up. It would actually be an interesting approach. The community car loan program. What's this?
They have like a sign-up sheet for the cars, and then it's crazy. You can find over it.
That's right. So think for next class. Try to come in with maybe an idea of something else that's, don't even think about something else that's wrong with it. Try to give me a scenario of what it would take to convince you to participate in this program. What would it take? Would they have to pay you? Would you have to pay for it? Does that credit system work? Is there something in between? Do you just assume it's all going to be for the better good and it'll just work out? What is the human approach that we would take? All right, so we'll pick up there next time.